Lesson 71, percent change of dimensions, and then the appendix lesson, find the equation of a line from 2 points. First off, what do they mean by percent change of dimensions? You have two terms here. We have dilation, which means percent of the original, dilation means it's bigger. So if the shape starts at 100%, a dilation means you add a percent of increase to it. A reduction means you start at your 100% and it gets smaller, so you subtract a percent, so a percent of decrease. And it's very important that you pay close attention to how it's being used. So if they said it's a percent of, that means it's going to be a certain percent from the total. If they said a percent off, that means you're subtracting a certain percent from the total and then you solve it. So let's take a look at an example here. One square is 50% larger than another square. If we just look at that part, 50% larger, you're comparing. If one shape is 100% and another square is 50% larger, it's 50 plus 50%. So the new shape, the other square, is actually 150% of the original one. So they're comparing it. One is 100%, the other one's 150%, a difference of 50%. Okay, so it's 50% larger. So keep that in mind. The perimeter of the larger square is what percent of the perimeter of the smaller square? So in order to solve this one, we're going to try to find the scale factor. You're comparing one shape to the other. If the smaller square is 100 and the larger square is 150%, I just compare the two. So I would have 150 to 100 because that's what they're asking you. So the order does matter. So it says what is that the perimeter of the larger square is what percent of the smaller. So you're comparing the larger one to the smaller one. So if I were to simplify this, 150 divided by 100 would just be 1.5. So we would have, what percent would that be? That would be 150%. And we're going to use that scale factor shortly. So this would be 150% as I had up here. The second part, the area of the larger square is what percent of the area of the smaller square. So now here's where we need to use our scale factor of 1.5. Remember, area is dealing with square units. Perimeter is just plain units. So if we take the 1.5 as our scale factor, so each side is 1.5 of the larger square side is 1.5 times larger than the smaller square. So when you're dealing with area and you're comparing percentages, you need to square the scale factor. And so if the scale factor is 1.5 or 150%, I would need to square the 1.5, and 1.5 squared is 2.25, which that would equal to being 225%. And so here they're saying the area of the larger square is 225% of the smaller square. So there's your keyword of. Now, if they were comparing the two, we would say that the area is 125% larger, because if the smaller one is 100%, 225% minus 100% would give you your 125%. So the larger one is 125% larger, but the area is actually 225% of the smaller one. So when you're comparing it, you subtract them. When you're actually saying what percent of the smaller one, you would say 225. And then the last part says provide examples of two squares that fit the description. So if I were to draw two squares, we'll just use smaller numbers here. Here's the smaller one, smaller square. So this is, if this is 1 centimeter, the bigger square, 1 times 1.5 would be 1.5. And that would be our comparison. And let's just say we did the perimeter. The perimeter would be 4 for this one, and the perimeter for this one would be 1.5 times 4 would give us 6. If we did 4 times 1.5, you would get your 6. So you can see that the smaller square times 150% would give you your 6. And then if we did the area, 1 times 1 is 1. 1.5 times 1.5 is 2.25. So you can see the area 1 to 2.25, or 100% to 225%. Next problem, problem 2. The towel shrunk 10% when it was washed. The area of the towel was reduced by what percent? Provide an example of the before and after dimensions of the towel. So first off, if it's 10%, the towel shrunk 10%, that's 10% on each side. So if it's 100% before you put it in the washer and dryer, now it's 10%, it shrunk 10%, so I'm subtracting 10% from that. That will give us 90%. And to compare that, we're comparing the new towel, which is 90%, to the old towel, which was 100%. That would give us 0.9 as our scale factor. And then since we are dealing with area, the area of the towel was reduced by what percent? I take my scale factor, or the new percent of what the new towel is, 9.9. And since we're dealing with area, we need to square it, which will give us 0.81. And then that 0.81, we would say that that number represents the area of the, so we would say that the area of the towel, the reduced towel, is 81% of the area of the original. So the original was 100. The reduced towel, or the shrunk towel, is 81% of that. If I subtract the 81% from that one, I would get 19%. So it shrunk 19%. The area was 19% smaller than the original one. Next one, there are two concentric circles on the playground. The diameter of the larger circle is 40% greater than the diameter of the smaller circle. The area of the larger circle is what percent greater than the area of the smaller circle. So here we are comparing. We're asking what percent greater. So we're going to have to take our two percentages at the end and compare them. So if the original one is 100%, so the diameter of the larger circle is 40% greater than the smaller. So if we have a smaller one, and let's say the smaller one is 100%, and the larger one is 40% greater. So this is a plus 40% greater. That would make this larger one 140%. And since you're comparing how much greater are the areas, so you're going from the bigger one to the smaller one, so 140 divided by the 100, that would give us 1.4 as our scale factor. And then we are going to take that and we need to square it because we're comparing the area, and 1.4 squared would be 1.96. But since we are comparing them, since the newer one, or the larger one, is 196%, the smaller one is 100%. To find out how much greater, I would subtract the two, and I would get 96%. So it would be 96% larger or greater. The area is 96% greater than the smaller circle. Next one, Becky reduced the size of the image on the computer screen by 40%. By what percent was the area of the image reduced? So we always start with the 100%, and it says that it was reduced by 40%. So if I subtract the 40%, that will give us 60%. And so now we compare the reduced size of the image and the original. So the original was the reduced one is 60. So you're comparing the reduced one to the original, which is 100, which will give you 0.6. And since we're dealing again with area, we need to square that scale factor, which will give us 0.36. And by what percent was the area of the image reduced? So we take the 100 minus, that would be 36%, and that would give us a 64% reduction. So it was smaller, the area was reduced by 64%. Next one, this is dealing with our same problem, but first we need to graph these points. So the vertices, 4, 4, put a point there, 4, negative 4, negative 4, negative 4, negative 4, and positive 4. Then draw my square. So that's the original one. It says sketch the square and its image after 125 dilation. So that means it increased. We multiply each dimension by 125%. So if I did 4 times 1.25, because 1.25 is 125%, I would get 5. So if I were to put my points down, I would have negative 5, 5. I would have 5, 5. And so this would be the dilated square. Now it says the perimeter of the dilation is what percent greater than the perimeter of the original. Well, the purple one, we would have, this is 10, and the black one, this would be 8. So we would have 10 by 10 by 10, and this one would be 8 by 8 by 8. We're comparing 40 of the large one and 32 of the small one. What percent greater? If you took our 40 and our 32 and divided them, because larger to smaller, you would get 1.25. So the larger one is 125%. The smaller one was the original, which is always 100%. I subtract the 2 and you would get a 25%. So we would say that it is 25% greater for the perimeter. Now if the area of the dilation is what percent greater than the area of the original square. So if the perimeter is 25%, we would just need to take this would actually be our scale factor of 1.25. So 1.25, I would need to square it, and that would give us 1.5625. So that would be like 156.14%. So if I multiply that by 100, that's how you'd get 156.25. So we're comparing the area. I would just take my 156.25 and subtract the 100%, and you would get 56.25% greater than the original one. Again, we're just comparing. That's what that greater part means. Another one, this one's very similar, except for now it's 150% dilation. So if I take the 4 and I multiply it by 1.5, because it's 150% dilation bigger, that would give us 6s. So our original one would have been, this would have been our original one with these coordinates. But then with a 150% increase, then it would be 6 all the way around. And we would just do everything else the same. What percent would the perimeter increase? Well, if the original was 100 and the new one is now 150% bigger, you subtract them, you would say it's a 50% increase. And then the area, it's a 150% increase, or 150% is the new one. We would just take our 150 divided by 100, give us a scale factor of 1.5. We would have to square that, and that would give us 2.25, which is 225%. And they're asking by what percent would it increase. We would just have to take our new percent, 225, subtract our 100%, and that would give us 125% increase. So this one is just the same as the last one. It's just now the last one was 125%, this one's 150%, same steps. Then its dimensions of a cube are increased 100%. By what percent is the volume increased? So with units, we just did 1 unit, so we didn't square anything, we just found the scale factor. With area, we squared the scale factor because you're using square units. Volume, you use cubic units, so you're going to have to cube the scale factor. So for this one, to find the scale factor from the larger one to the smaller one, the side of the larger cube is 2 to 1 in the smaller one. That would give us a scale factor of 2. If that's the scale factor, and we're dealing with volume, we would have to cube that, which would be 8. But this is dealing with percent. So if this was, the smaller one is 100%, 2 times greater would be, this would have to be 200%. So if we did 200%, if you cube the 2, that would be an 800% increase. So how much, by what percent is the volume increased by? The larger one minus the smaller one would give us a 700% increase. The next one, suppose the dimensions of the larger cube in example 4, so the one on the left, were increased by 100%. What would be the edge of the expanded cube? Well, if the original was 2 inches, in you increased it 100%, which really means you're doubling it. So add another 2 inches, that would give you the side length of 4 inches. And then the volume of the expanded cube would be what percent of a 2-inch cube? Well, if you're comparing 4 inches of the big one to 2 in the small one, that would be 4 divided by 2 would be 2. That would be our scale factor. You cube it, that would be an 8. And that 8 would represent, if we would take that 8, and that 8 would be represent, since we're dealing with percentages, multiply that by 100, that would give us an 800% increase. And then the last thing for today, looking at finding the equation of a line given 2 points. So the slope formula, y2 minus y1 divided by x2 minus x1, you need to use an ordered pair and substitute that into the y equals mx plus b format to find your b. So in order to find the slope here, this is your x1, y1, x2, y2. We have negative 4 minus 2 divided by negative 3 minus 1. So give us negative 6 over negative 4, which reduced by 2 halves would give us a positive 3 halves. So that's our slope. And then I just pick a point to use to put in there. I'll just use this point. So my y is 2 equals 3 halves. My x is 1 plus b. So 3 halves times 1 is 3 halves. So I'm going to subtract 3 halves on both sides to find my b. 2 minus 3 halves, or 2 minus 1.5, is 0.5. So my equation would be y equals my slope of 3 halves x plus half. And that would be our equation for that line that goes through those 2 points. This next one, we'd have 2 minus 5, because this is my x1, y1, x2, y2, divided by negative 2 minus a negative 4, which gives us a negative 3 over 2. Plug that into my equation. I'm going to use this point. It doesn't matter. I'm just going to use the second one. So 2 equals negative 3 halves times a negative 2 plus b. I can divide a 2 here and a 2 here, so now I have a negative 1 times negative 3, which is 3, plus b equals 2. To solve for b, I subtract 3. Negative 1 equals b. So my equation, y equals, and then my slope, negative 3 halves x minus 1. So just using slope formula to find our slope, use one of the points to find our b to write our new equation. So that is our lesson today on percent change of dimensions and writing an equation of a line through slope and a point.